Welcome to Season 5 of the Let's Talk Data podcast series, presented by SAP, where we explore game-changing technologies with leading experts.
Hello, everyone, and welcome to another episode of Let's Talk Data. My name is Ginger, and I'm your host for today. I'm really excited today because we have three colleagues from one of our fantastic partners, Camelot. Today, I'm joined by Andreas, Stefan, and Julia, but we don't call him Andreas. We're all good buddies here, so we're just going to call him Andy. So we've got Andy, Stefan, and Julia. So why don't you guys introduce yourselves to the audience, and thank you so much for being here. We really appreciate you taking the time to join us on our podcast today.
Hi, Ginger. Thanks for the invite. This is Julia. Pleasure to be here. At Camelot, I'm responsible for strategic alliances and demand generation activities to expand the global Camelot footprint. And as part of these activities, we also participated in the SAP Data Intelligence Content Sprint some time back, where we as Camelot developed two innovative use cases based on SAP Data Intelligence. So I'm really excited that we have the chance to be here today and share some further insights.
Hi all, my name is Andy and I'm Head of Intelligent Data Management at Camelot, focusing on enterprise data orchestration and holistic data management. And I'm happy that we can be here today.
Hey everyone, and this is Stefan, and I'm leading our Data Science Innovation Squad here at Camelot. So what we basically do is twofold. First, we respond to requirements that revolve around specific data science use cases. So we create minimum viable products and then take them into production. But we also start at readiness for data science in production, so the more strategic consulting part of the play.
Well, thank you. Andy, Stefan, Julia, I'm so happy that you guys are here. I met Camelot during the content sprint that Julia mentioned earlier for data intelligence, where we brought around all these partners and they created some fantastic content for us. And I really loved what Camelot is doing. They're so innovative. They have such a unique approach. And what they're going to do today, I'm really excited about it. The topic, our title for this podcast is From Playground to Production, How to Become a Data-Driven Company based on an enterprise architecture perspective. We're doing a lot right now to try to address enterprise architects, so I really love what they're going to do. So they're going to do this podcast in the form of a role play. Julia's going to be the customer. Andy and Stefan, just like in real life, doing what they normally do, will be the data science and enterprise architect experts from Camelot. All right, you guys, take it away. So just to set it up, it's going to be at 9 a.m. in the morning. Julia, Andy, and Stefan are walking into the meeting room, and they're ready to begin their planned 30-minute alignment for evaluating the options and approaches for redesigning the company's enterprise architecture to fit in with the company's data-driven business transformation. So take it away, you guys.
Good morning, gentlemen. Nice to meet you. Welcome to Super Retail. Hope you have arrived well.
Morning, Julia. The pleasure is mine. We couldn't miss the big logo of Super Retail while driving down the road.
Morning, Julia. Yes. I've been here actually once before, and I had a talk with your colleague Marcus from IT.
Good to know that you already connected beforehand. As you already know, our company Super Retail would like to change our business process to innovation-oriented and data-driven. We would like to profit from data. Everyone on the market is saying, data is the new oil. We would like to transform some of our business processes into a data-driven approach. And the management team has appointed me to be fully in charge of the whole program. I'm officially the program manager for the DDBP program, which stands for Data-Driven Business Process.
Wow, congratulations. That's an important decision and move from Super Retail. It makes a lot of sense since we're living in such an uncertain, complex and dynamic world. Strategic, technical and operational issues, all of them are very relevant here, right from the start. Can you tell us a bit more about the background and the situation right now?
Sure, no problem at all. Super Retail is one of the top 10 gaming retailers in our country. Our customers are majorly young adults. They tend to use their smartphones or computers for browsing and purchasing the video games. Most of these purchase orders are processed via our online store. This is the data source where most of the data are coming from. Altogether, we have around 500 stores. Right now, the Enterprise Business Warehouse has a total amount of 20 terabyte of data, and we expect additional 300 terabyte of data in the next 5 years.
Oh, well, then we are talking about a really huge amount of data, and the data size also continues to grow. So considering that amount of data Super Retail currently possesses, you probably need to take a closer look at your current enterprise architecture. So besides the business process related changes, that is, you would need to ensure data science and intelligent data management architecture.
In fact, we've been partnering with another leading business intelligence company for 5 years. They were responsible for developing the existing data warehouse solution. Besides that, Super Retail has some forecasting applications in place, which can forecast some certain changes of the market. However, these forecasting applications are all running on-premise, and the performance is sometimes poor due to the increasing amount of data. That's the reason why we are now open to the cloud and hyperscaler option. But I still don't understand why we need to adapt to this so-called data science and intelligent data management architecture, which you just mentioned, Stefan. Why is our well-established business warehouse system not sufficient anymore?
Well, actually, we would have to answer your question by asking 3 other questions regarding organization, infrastructure, and data storage. So let's begin with the organization part. Well, do you have a dedicated data science team to handle large amounts of data in your organization?
Yes, we have. You already met Marcus, and we have another colleague, Peter, who is sitting next door to the IT office. We hired both of them 3 years ago. They are both data scientists with a degree in mathematics. However, the difficulties are that nobody really understands how the forecast works except themselves.
Okay, well, let's look into the infrastructure part. How does your infrastructure look like?
Well, we gave them very powerful workstations. We also plan to upgrade their workstations regularly.
Okay, get it. And where is the data stored they're working with? On the local hard drives of the data scientists' workstations?
As far as I know, the IT department usually makes a copy of the data with a portable hard drive for the data science colleagues, and then passes the copy onto them as required.
Okay, understood. Then talking a little bit about the forecast application, I assume the forecasts get updated regularly. How often do these updates happen?
I think those updates happen once per week. Our IT department gathers the data of the past 12 months so that the forecasts can be calculated based on the most up-to-date data.
Okay, so to put it into one sentence, you use external storage devices for the storage itself and manually transfer the data between IT and data science teams. The forecasting applications are developed by 2 colleagues locally, and they also running locally. Is that correct?
Yes, that's basically the current situation. In your opinion, do you think we are in a position to extract the most value from our data already?
Not quite yet, but you're asking the right question. Before we can elaborate on the road ahead, we first should do an assessment of your current strategy and architecture based on 4 different pillars: organization, technology, infrastructure, and operations. These 4 pillars consist of cross-industry best practices. They're developed by Camelot and have already been used for data-driven transformation projects by customers in various sectors globally. These 4 pillars constitute a comprehensive strategy to enable organizations to fully harness the power of data that they have already. On top of these 4 pillars, we build our data management strategy and architecture. For the starting point, you're going to need a data lake. A data lake captures the data and events from diverse source systems. Kindly be aware that we don't suggest replacing your data warehouse with a data lake. They should rather be used in combination. Also, you need a data catalog, which collects the metadata and works as the so-called data of data. It can help to prevent you from getting lost in the data lake.
Then also importantly, we need like a holistic and complete concept regarding that data management. So including data pipelines and the before mentioned data catalogs. And as far as I'm concerned, currently you have no such strategy in place, but that is needed to successfully transform super retail to a data-driven company. Before we go into the details of these 4 pillars, we also need to take a look at the overall strategy and architecture perspective, as mentioned. We suggest that you need to define your overall data science and intelligent data management strategic target. On the architectural side, you need to have a high-level architecture in place, or at least in mind.
Okay, that's actually quite a lot. Please help me understand. How can we design our high-level architecture?
Well, we suggest starting by asking yourself questions like, where do you get your data from? How do you process those? And who is going to use the data and data products, and for what purpose then? Apart from that, you also need to provide guidelines for the architecture and guidelines for the technology in order to have a robust foundation. We would need to apply established conventions for architectural design and cloud adoption based on that present and maybe also already future needs of your company. So I figure some workshop sessions with your architects would be quite appropriate.
Okay, that sounds great. Let's do it and plan for the upcoming weeks. We now talked about the architecture. I do see the necessity to change our setup for our data-driven processes. How would you suggest us to continue? Could you elaborate further on Camelot's 4-pillar strategy for data-driven transformation? I would like to know more about the other parts.
Sure. Let's continue by discussing the organization pillar. To be honest, having just 2 high-end computers and data scientists doesn't follow a proper strategy. There is currently no organization in place, which makes the decision-making process quite simple and fast. But on the other side, there are no governed processes to manage solutions and requirements end-to-end. We understand data intelligence as an activity that requires close interaction between various stakeholders. Firstly, the infrastructure and architecture team defines the integration layers. They're the data engineers who are going to provide the standards and the common principles. They also ensure the correct technology is chosen for the task. Secondly, we have the data science team, which consists of data scientists, of course. It manages data and defines the data quality rules, governs the data and integration. This team is also responsible for provisioning the data as well as building and evaluating intelligent solutions. And finally, there's the competence center, which is like the integration point to the business. So they're the peers who will fill gaps in business understanding for the tech team, and together with you, they're collecting the business demands and assessing them. All 3 teams work together and are governed by business needs and goals. This governance and collaboration functionality can be achieved easily by SAP Data Intelligence. You only need to define correct roles and assign corresponding policies to the users.
Okay, thank you for this additional information. The need for a data-driven organizational strategy is clear for me now. I'm curious though, how do you manage the technologies for such complex projects with various moving parts? I would like to see how you would do it in the case of, let's say, real-time stock predictions.
Well, up until now, we haven't taken a closer look at the technology aspect. For example, what kind of programming languages and frameworks are you using right now with your data science colleagues?
Well, I believe the team is using the programming language R.
Okay, so only R and no other programming language or anything around that?
Yes, I'm pretty sure about that, because they gave us a short training on how to use R some months ago.
Yeah, well, only using one single programming language for sure lowers the possibility to fully benefit from other various newer technologies and services that are available right now out there. Basically, you have limited options to integrate with active external services, other existing models in data science and beyond, and also more generally speaking, components that would stitch together your architecture. Basically, what we would first suggest is using containers to manage all the moving and yet closely integrated technological parts. So what's a container, for example, very briefly illustrated? A container is like a virtual area in which your team's solutions will be deployed and executed. So these enable you to basically have the best fit technology in place for building solutions that fit your organization's requirements. And they are tool agnostic and programming language agnostic as well. So you can basically choose any language tool or database that best fits your scenario. You build it once and it runs basically anywhere. More specifically, you may want to measure, for example, the impact of sales activities on a store level. To do that, we have to integrate a high volume of data sets. We have to transform them. We have to execute and train prior to that machine learning models. And we have to integrate all of that back to a user interface. So that means that a lot of different technologies and services must be in place and integrated. There's a multitude of options, from serverless functions over to managed multi-cluster architectures, but the choice pretty much depends on the task. So for your scenario, Python might be, for example, the programming language of your choice, but when it comes to a statistical analysis of that data, perhaps Python is probably not the best fit. So choosing R as a programming language might be even better, or you might want to use the new player on the market called Julia, just like you, by the way. It promises to be even faster than both Python and R. So we always must have a look at the market and on the trends to get the desired solution. We build that and then we pack it in these so-called containers and ship them into production, where, as mentioned, they are language and tool agnostic because they are encapsulated solutions that run anywhere. In fact, SAP Data Intelligence also makes use of such containers to run data pipelines, which can have multiple programming languages and integration options to other technologies. Long story short, what we usually do is take specific use cases and find the right mixture to take them towards a sustainable value contribution. The neat thing about cloud services in that sense is that you elastically can right-size everything according to your needs and turn off services and machinery in case you don't need them anymore. So what I would suggest is we pick a handful of feasible use cases and start taking them into the cloud.
Of course, that sounds very good. I will connect you to the team so you can get started right away. You also mentioned various programming languages, tools, and technologies. Would an effective implementation for that require a massive technological infrastructure setup?
Your question concerns the third pillar, which is the infrastructure strategy. At Camelot, we have developed a method called Grow As You Go for infrastructure setup. It has 4 key concepts, namely cost efficiency, flexibility, security, scalability, and performance. You cannot set up all the required infrastructure in a single computer, but with the cost efficiency, we can ensure that only those resources are provisioned for infrastructure that are essential for the successful functioning of the solution and no more. Flexibility in our case would be provided by using containers to make sure that the solution can benefit from diverse technologies and is available in different time zones, for example. Security in your context could mean that your data never leaves the country or, for example, the European Union if you're using hyperscalers. It also entails failure and disaster recovery. And scalability and performance would allow you to add more resources to ensure speed and availability of your solution as demand for it grows in a seamless way, and only incurring those extra costs when it becomes necessary. By utilizing these 4 dimensions, we can keep your infrastructure setup grow as you go. The grow as you go method is not just for hyperscale deployments, but is equally applicable to on-premise or hybrid scenarios. You could be using SAP Data Intelligence Platform on-premise to integrate data from different data sources, like, for example, get data for your forecast from the data warehouse or data lake in the future. On the other hand, you can pass the data to other hyperscalers using SAP Data Intelligence as an integration tool if you would like to do your forecast in one of the hyperscalers.
Okay, I think I have a better grasp on the subject now. Thank you very much for the explanation. We now have the data, the models, and the infrastructure for SAP Data Intelligence. Is that all? Or am I missing something?
So far, we've discussed organizational, technological, and infrastructural pillars of a data-driven company. Now we'll talk about the final pillar, which is the DevOps strategy. So you have now all necessary components in place, let's assume that. But to effectively manage them all, you need to have an overall operations and development management strategy, right? So what that means is it would ensure that your solutions are tested before being pushed to production. And same goes for the different model versions that data science guys are working on at any given point in time. So also managing the life cycle of models in data science and also the data products. And then, also automating that to a certain degree. Like questions pop up in my mind about how do you host an endpoint to a model, for example. And if you want to fully integrate that into your strategy, then you would come up with a continuous integration and continuous delivery pipeline, or in short, CI/CD, where you would use tools like GitHub and Jenkins and the likes. So that DevOps strategy should enable to monitor and manage downtimes as well, and have policies for disaster recovery, scheduled backups, fallback machines, redundancies, and so on and so forth. It should also enable logging and tracing for quick resolution of issues, and should also include strategies for a robust user management. And these concepts will enable you to fully leverage your data.
Okay, understood. Much appreciated. Thanks for your time today. Since we are running out of time now, I would like to outline my key takeaways from this short meeting. I believe we are all on the same page about the fact that our enterprise data transformation will be challenging. Organizational, technology, infrastructure, and operations are the important factors to be analyzed and evaluated. In order to achieve our targets, we must have a data-driven strategy and architecture in place. Would you like to add anything?
You're absolutely correct. At the end of the day, it is about the balance between the different factors. For example, the on-premises way of developing data science solution with a limited amount of resources, which we at Camelot refer to as playground architecture, is more secure since your data never leaves the premises. Whereas the hyperscaler way, for example, with a dedicated organization and infrastructure, is more flexible and scalable. With SAP Data Intelligence, together with other hyperscalers, you can have benefits of both at the same time.
Exactly. Well, Julia, I hope you found these first insights quite useful. We're actually looking very much forward to our collaboration on your data-driven journey. So if there is anything else that comes up in between, please feel free to reach out to us anytime if you have those questions.
Definitely. Thanks again for your time. I'm sure we will have a lot more discussions in the coming month that cover all the aspects we discussed in more detail. Bye until next time, and have a nice rest of the day.
Thank you. See you next time.
It's been a pleasure. Thank you so much.
So I would like to thank Camelot for joining us today and doing this excellent role play on enterprise architecture and how it helps you become a data-driven company. If you'd like to learn more about what Camelot is doing with SAP and data intelligence, you can go to community.sap.com and search for Camelot Data Intelligence, and you'll find several blogs that they've done there. Andy, Stefan, Julia, how else can we learn about more what you guys are doing with enterprise architecture and just what Camelot's doing? What do you recommend?
First, thank you very much for the opportunity and the chance that we could have been here today, Ginger. If you would like to learn more about what Camelot is doing in the data and analytics area, you can visit the website data-driven-leaders.com.
Thank you, and we hope to see you on a future episode of Let's Talk Data podcast series.